All right, we have a problem where they are firing a gun. The fact that it fires a 1.5 kilogram shell is irrelevant. It is important that it goes 120 meters per second and that it's going at 30 degrees. So in this problem, they want to know what max height is. So they want to know the maximum height in the problem. And they want to know how far it goes, so they want to know x. The velocity in the vertical direction is 120 times the sine of 30. This equals 60 meters per second. So in the y direction, if I split the problem in half, velocity here is going to equal 0. And velocity here, let's call that velocity final when it hits the ground, is 60 meters per second. And A is going to equal 9.81. So with 3 variables, I can use who cares to solve for height. I would use VF squared equals VI squared plus 2AX. In this case, the distance x is what we're solving for. That's going to give us the height. So we should call that y. VI in this case, VI here is 0, so it's going to cancel out of the problem. I'm going to rearrange to solve for y, so it's VF squared divided by 2A equals the height y. When I plug in these numbers, I'm going to square 60 squared divided by 2 times 9.81. And it's going to give me 184. That's pretty bad writing there, hang on. 184 meters. That's going to be the height that it travels. So 184. All right, to solve for time, I've got the distance of 184. I've got VI equals 0 up here. VF equals 60, and I got A equals 9.81. Since I want time, I've got 4 variables. The one I'm going to use is y equals VI t plus 1/2 a t squared. In this case, again, VI equals 0, so that's going to cancel out. I'm going to rearrange the problem to solve for t. So it's going to be 2y divided by a, take the square root, it's going to equal t. So in this case, 2 times 184 divided by 9.81, take the square root of that guy, and that's going to give me t for half the distance. It's going to equal 6.1 seconds. That would be the time for one side, 6.1 seconds. So over here I would also need 6.1 seconds to do the first half of the trip. Combined, I've got 12.2 seconds that it's going to travel in the x direction. In the x direction, let's get that 12.2. I've got 12.2 seconds that it's going to travel in the x direction. In the x direction, the only equation we can use is velocity equals distance over time. To solve for x, I have to use velocity times time equals x. So I've got time is 12.2 seconds. Velocity in the x direction equals, in this case, 120. It's the cosine of 30. I multiply these together, velocity and time, and that's going to give me the range in that direction. And that equals 1267 meters.